Houston, Tranquility Base here. The Eagle has landed. Roger.
When I was a little girl and people were always asking me, what do you want to be when you grow up? And I used to always go, I want to work up there. As an engineer, you dream of a job like this where you get to follow in the footsteps of some of your childhood heroes. And of course, for me, the Apollo missions, seeing these folks on TV step on the moon and work for NASA, as an engineer, it's just a dream to be able to say, you know, I want to do that too, and here I am.
Only a dozen Americans have kicked the dirt on the lunar surface. It was a bold and dangerous engineering achievement driven by a political agenda.
The Apollo program was important because it showed that we could leave our home planet and visit an object like the moon. However, what we want to do next is learn how to live and work off of our home planet on another planetary surface like the moon. By developing this capability, we'll be able to know how to go throughout the inner solar system, which has many important destinations, both for science understanding and also may have economic importance for not only our generation, but for future generations.
The Soviet Union and the US had peppered the lunar surface with soft and hard landing spacecraft. The Soviets' Luna 24 was the last of that program, returning soil samples that contained traces of water. Much of science and technology has advanced since the 1970s. The mechanism of world politics has evolved, new partnerships have formed, new players are looking skyward, and more recently, private enterprise has taken up the challenge. With the faintest of inklings that there may be usable water on the moon, a forensic focus has turned to the southern polar region. Scientific programs in the 90s refocused on the moon. Japan was the first to revive lunar research and only the third nation to achieve lunar orbit with Hi-10 on a dust-collecting mission. The US followed with Clementine, a joint NASA military project. It completed a mapping survey of the lunar surface, along with gravitational data and evidential proof of possible water ice hidden in a south polar crater in permanent darkness. 4 years later, Lunar Prospector mapped lunar resources, gravity and magnetic fields. It was also impacted into the southern region of the surface to elicit more evidence of water ice hidden in the craters. Europe's contribution to this resurgence in lunar exploration began with the launch of Smart 1. This tiny, ion-propelled satellite catalogued key chemical elements on the surface. It also enhanced the theory that the moon was the result of a collision between Earth and a smaller celestial body called Theas some 4.5 billion years ago. Japan's second probe was Selene, better known in Japan as Kaguya. It continued extensive observations of the lunar crust and also carried the first high-definition cameras into lunar orbit, giving us a clearer picture of the rugged surface. Another proof of capability, this time by India. It also carried a NASA mineralogy mapper and an impact probe. It played a key role in the confirmation of water hidden in the southern lunar pole. 8 months later, NASA launched the Lunar Reconnaissance Orbiter, or LRO. It has spent the last few years mapping and scanning the lunar world with sophisticated sensors and continues to return a wealth of data.
The Lunar Reconnaissance Orbiter is, as its namesake says, a reconnaissance mission to the moon. Our job is to take a suite of very powerful scientific instruments and make an atlas of the entire moon, in some places in very great detail. Topography, mountain heights, mineralogy, temperatures, abundances of resources, including potentially the intriguing possibility that there's water at the moon. We put all this together into a data set by flying low over the moon for a year. This is the data that the people designing the human systems, designing the systems, picking the sites, need to take us back to the moon.
This robotic mission commenced operations in June 2009. It was hoped the suite of sensors would fulfill several scientific goals, not only for the Moon, but as a framework for understanding planetary processes throughout the solar system.
The LRO instrument suite is comprised of 6 instruments and 1 technology demonstrator. And they are geared towards providing us a variety of data sets ranging from a thermal map of the Moon, global topography, and most importantly, looking for resources like water ice on the Moon. The entire suite should provide more of an atlas as opposed to a map, so that we know where to go on the Moon, where to have the safe landing sites, and where to put things like lunar outposts in the hopes of having human exploration in the near future.
The data being returned from LRO and the other probes draws a clear image of the evolution of the lunar surface and why it is composed of exactly the same elements as the Earth. After coalescing from the Earth-Theas collision, the proto-Moon cooled, then suffered several major collisions from orbital debris, which created many of the largest surface characteristics, including the mares. Cratering continued relentlessly over the millennia, drawing the familiar lunar vista.
My name is Lynn Carter. I'm a research space scientist, and I work with the Planetary Geodynamics group here at Goddard. I study the geology of planetary surfaces, the Earth, Moon, Mars, Venus. There's a lot of things you can learn about the Earth by studying other planets. For example, on the Earth, we have a lot of erosive processes. You know, it rains, it washes parts of the surface away. We have plate tectonics, which recycles the crust. But on other planets, those processes don't necessarily occur. So for example, when we look at the Moon, we're seeing a surface that's much older. We can use impact cratering on the Moon to sort of understand how many impacts happened, the size of the objects that were hitting each other in the early solar system. One of my favorite things is to use radar remote sensing. For example, on Mars, we can use radars to sound all the way to the bottom of Mars polar caps and see all this layering within the polar caps. And on the Moon, we're using it to study impact cratering. Sometimes when an impact crater is formed, a huge sheet of melt is thrown out. This melted rock flows across the surface, but then over time, it's covered over by stuff from other impacts. But with the radar, it just blows right through all of that, and you can see this beautiful image of the melt flow coming out of the crater.
Launched with LRO was LCROSS, or Lunar Crater Observation and Sensing Satellite. It deployed sometime later than LRO and had a finite mission. LCROSS and the rocket stage that delivered it were deliberately crashed into the craters of the South Pole, whilst LRO orbited above and observed the impacts. The debris and gases thrown up from the lunar surface were closely studied by LCROSS as it too descended to the surface. The missions found evidence that the lunar soil within these shadowy craters is rich in useful materials. The Moon is chemically active and has a water cycle. Scientists also confirmed the water was in the form of mostly pure ice crystals, which had not seen sunlight for billions of years. LRO has continued to operate in polar orbit, making observations of the South Pole, and with repeated flyovers, it has drawn up a detailed map of neutron densities in the region, revealing where hydrogen and thus water can be found within the lunar soil. The importance of this discovery cannot be overestimated. Having this resource in situ means independence from the cost and effort of bringing water from Earth to the Moon. It can be used for creating rocket fuel, oxygen to breathe, water to consume and to irrigate crops, and used in other processes to manufacture building materials from the lunar soil. Launched in 2007, NASA's 5 Themis spacecraft have now successfully completed their 2-year mission to determine the cause of geomagnetic substorms. Because they are continuing to work perfectly, NASA redirected the outermost 2 spacecraft to the Moon. This new mission was called Artemis, and they studied the magnetospheric environment near the Moon.